Hi, good morning, guys. I hope you are having good time fighting Corona. Now we are going to move to lecture 6, which is techniques of circuit analysis, part 2. Last week's we took two techniques, circuit reduction and nodal analysis. I highly advise everyone before you listen to this lecture, you have to revise circuit reduction and nodal analysis, specifically the nodal analysis, because as I told you, if you remember from last lecture, that KVL and KCL are intuitive method and they can solve everything. So this chapter is techniques of circuit analysis. We have different techniques. These techniques also can solve everything. So your job actually is to know which technique can solve which type of problems, because everything will solve everything. So you have to be smart to know when you see a problem, I will use nodal or mesh or the regular KCL and KVL. This is the target. So today we will have two more techniques, mesh analysis and source transformation. So stay focused. What is mesh analysis? Let's first define what is mesh. Mesh is a loop. Mesh is a loop, but this loop does not contain any other loop within it. This is a loop, right? بس مشكلة اللوب دي ايه؟ ان هي it contains three loops. This is one loop, this is the second loop, this is the third loop. So this is a loop, a regular loop. But can we call this loop a mesh? No, we cannot. Why? Because it contains other loop within it. So to understand the mesh, a mesh is a loop which does not contain any other loop. يعني المش هي loop برضو بس ما فيش جواها loop تانية. طيب بنفس الدefinition دي how many mesh do we have in this problem? We have only 4 meshes. تمام؟ طيب the second definition we would like, so this slide is about definitions. We are defining what we are going to use later on. Okay. A mesh current is another definition that exists is only in the parameter of المش. يعني أنا طول ما أنا جوه المش, this is the mesh, I have only one current exist. طيب لو أنا في المش دي, which current exists in the parameter of المش? I2. خد بالك احنا هنا we did not say that I1 is passing through each element inside the mesh. ما قلناش كده خالص. احنا قلنا جوه البارامتر ده انا عندي I1, ادي البارامتر ده انا عندي I4, جوه البارامتر ده انا هقول انا عندي هنا I3. So these are your unknowns. I1, I2, I3, R4. So these are the unknowns. Okay. زي ما اتفقنا في النودل في last lecture, النودل will has predefined unknowns. ده غير الكي سي ال والكي في ال. في الكي سي ال والكي في ال each one of you has to redefine their unknowns. But in the nodal analysis the unknowns are defined, which are the node voltages. يبقى النود voltages هي unknowns بتاعتنا اللي انا I'm trying to identify or obtain. For the mesh analysis our unknowns are the mesh currents. بمعنى انا عندي هنا 4 meshes, كل mesh هيبقى في البريمتر بتاعها في current. This is what I'm trying to get. يبقى كده عدد الايكويشنز معروف من قبل ما ابدا ولا لا؟ yes. يبقى انا هنا عندي 4 meshes, I will have 4 equations and 4 unknowns. عندي 3 meshes, I will have 3 equations and 3 unknowns. And these are what I am trying to obtain or identify. لحد كده في مشكلة؟ تمام. يبقى كده سعادتك المطلوب منك ان انا اعرف في اي مسألة هستخدم نودل ولا مش. طب هيبقى اول حاجة هيبقى بيزد على ايه؟ لو النودل مثلا بتديني 3 equations والمش بتديني 2 equations, يبقى مين احسن؟ المش definitely. طيب خلي بالكوا تاني, المش والنودل بنديفاين المش currents وهناك بديفاين النود voltages, وبعد ما بجيبهم بشوف انا ايه المطلوب مني to calculate. Okay. So we will face only one problem. What is the problem? Here I know the current pass through R1 اللي هو I1. The current through R5 هو actually برضو I1. What about this element? This is the intermediate element between two meshes. I am not going to have only I1 or I2 passing through R6. So R6 will have a combination between the two currents. I will explain this in details later. So now, what I want you to get out from this slide, the following. First, what is the definition of a mesh? What is the definition of a mesh current? What number of equations we would like to obtain. This slide is the most important slide in the whole lecture. يعني لازم نركز جدا جدا جدا. أول حاجة عايزين نتكلم على احنا اتفقنا ان المش current هو الكرنت اللي بيمشي أو اللي موجود في البارامتر بتاع المش. What about the intermediate element? If there exists an element between two meshes زي R6 اللي في ال previous slide. طيب. If we assume the current direction in this element is downward like this. So this current has to take mix between I2 and I1. How can we write this current? يبقى تاني كده we are trying to identify the current between in the element between any two meshes. Okay. Now, if you look closely, you will find this current direction is same as I2 and in the reverse direction of I1. So this intermediate element has a current in the same direction of I2. يعني element ده ماشي فيه current في نفس direction I2, which means that I2 is the dominant current. يعني لو أنا current ده واخد شوية من I2 وشوية من I1, فمين في الآخر اللي عمل domination I2؟ يبقى أقدر أقول إن الكرنت ده هو I2 minus I1. ليه أقدر أقول كده؟ لأن eventually I2 is the dominant current because the total current was at the direction of I2. تمام. هنكتبه بقى. اوكي. طيب. لو ما بين التو meshes عندي current source. What if I have a current source in between the two meshes? This will mean there is a relation between I2 and I1. We would like to identify this relation. هنشوف as if ان ال current source ده is the resultant current between I1 and I2. How can we calculate the relation or identify the relation between I1 and I2? Simply as this. 4 ampere in which direction? I1 or I2? This is I1 and this is I2. Okay, نشوف. This is I1 in the same direction of 4 ampere and I2 is in the opposite direction of 4 ampere. So I can write I1 minus I2 equals 4. You see? As simple as that. So now if we have element between two meshes as a resistance, now we know how to write the current passing through this resistance. If the element between two meshes is current source, this will give us extra advantage because we will know the relation between the two mesh currents. How to identify the voltage drop in terms of mesh current? ازاي نعرف بقى نكتب volt in terms of المش current ده؟ خلينا نبص هنا. This is single element. I would like to write V1 with using Ohm's law, V equal IR. So I1 is in the correct direction from the positive to negative. So we can write the voltage as V equal I1 R1. We will face problem not in the single element, but we will face problem in the element common between two meshes. As this, we have two currents. Which one is dominant? And here the resultant current is not identified, but easily you can identify the resultant current. Here is the positive and here is the negative. So the resultant current has to be like this. ليه؟ عشان الكرنت بيمشي من البوزيتيف للنيجاتيف في الريزيستنس عشان الريزيستنس always absorb current. حلو قوي. So can I write this resultant current? Yes, I can. هيبقى ايه بقى؟ مين اللي في نفس الدايركشن؟ I1 minus I2. يبقى this is the resultant current. I need to write a voltage. يبقى voltage equal IR. So the resultant current times R1 is V1. Okay. As I told you, mesh analysis is a systematic technique or a systematic way. We are using specific steps to do the equations, and the equations here is according to the number of meshes. فخلينا أول حاجة نشوف ازاي نكتب ال systematic equations دي. طيب خليني أسألك سؤال. If I'm going to solve this problem using a noodle, where should I put my ground? I should put my ground here. Why? Because this node will be V1 and this node will be V2. I mean known يعني. And this is only unknown node, so I will have to write single equation to identify the unknown voltage. حلو قوي. طيب خلينا نشوف بقى بالمش. First, to solve using المش, أول حاجة تعملها identify the number of meshes. How many mesh do we have? 2. Second step, assign mesh currents. Okay, طيب. If you look closely, you will see that I assign the two mesh currents oriented clockwise. في الكي في ال والكي سي ال زي ما اتفقنا انا حر تماما اخد اللوب دايركشن بتاعي clockwise or counter clockwise. في النودل analysis زي ما قلت لك كنا بنعمل ايه؟ كنا بنassume at each node the currents are leaving and repeat this assumption at the next node. Here we are going to do KVL. في النودل كنا بنعمل KCL to get voltage. هنا احنا هنعمل KVL to get current. Okay? طيب فال KVL بقى how we do the KVL? We will do the KVL all currents all loop direction has to have same orientation. So either all loops have clockwise orientation or counterclockwise orientation. I mean all meshes here. طيب لحد كده في مشكلة؟ جميل. So we assign the mesh currents to have the same orientation. Third step, apply KVL to each mesh. يبقى third step هعمل KVL. يبقى زي ما قلت لك for mesh analysis we are doing KVL to find current. How to make بقى this KVL? We will have no problem at any elements that inside the same meshes. We will have problem here at this element because this is an intermediate element between two meshes. Okay, let's do mesh 1. From here to here I have V1. From here to here I have I1, R1. This is the voltage. So this is the problem here. How can I write the resultant current? Which current is dominant? Is it I1 or I2? يعني احط الكرنت اللي ماشي في R3 ده ازاي؟ الدايركشن بتاعه ازاي؟ تبع I1 ولا تبع I2؟ ما انا هنا مش عارف مين الدوميننت. هل هو بمزاجي؟ لا مش بمزاجي. As long as I am in mesh 1, so the dominant current will be I1. طول ما انا في mesh 1 الدوميننت current هو I1. فهكتب الفولتج ازاي؟ هقول R3 times الديفرنس بقى مين الدوميننت؟ I1 minus I2. يبقى كده الفولتج is written. هقول الكلام ده equal to 0. تمام؟ لحد كده في مشكلة؟ تمام. اهي. طيب خلينا نرجع بقى نكتب mesh 2. Once we moved to mesh 2, so who is the dominant current? Which is the dominant current? I2. I2 هو الدوميننت. يبقى لما اجي write ال KVL at this element at mesh 2, so I2 is the dominant current. طب هكتب الفولت ازاي؟ خلي بالك انا بكتب هنا equation of voltage R3 times which is the dominant current here? It's I2 minus I1 plus from here to here the voltage is R2 I2 from here to here, so I will write plus V2 equal to 0. Let's see it in a nice way. This is how we write it. Okay? And then we have two equations in two unknowns solved simultaneously to find the I1 and the I2.